everyone, this is Soumya and today we are going to discuss about solid state chemistry, in which we are going to discuss about the crystal lattice, interfacial angle, unit cell, type of unit cell, classification on the basis of axial length and bond angle. So first of all, before starting these subtopics, we have to understand what a solid state chemistry is exactly. It is solid state. It is a physical state of a matter. How we can define solid state on the terms of two things. First of all, two factors. First of all, the intermolecular force of attraction, and the second is the thermal energy. As we know, the more the intermolecular force of attraction between the atoms and the molecules, that state of matter is considered as a solid state. Secondly, the thermal energy between the atom and molecules, when it is very low, thus that state is considered as to be the solid state. In this way, now first of all, starting with the crystal lattice, then what is a crystal lattice? It is a 3D arrangement of the lattice points. What are the lattice points? It can be atoms, molecules that are arranged in a crystal lattice. And especially in a unit cell. Then what is a unit cell? We know that unit cell is the smallest part of the complete crystal lattice. On repeating again and again the crystal lattices, repeating again and again the unit cells, a whole crystal lattice form. Okay, so second thing is, here we are going to discuss about the interfacial angle. What is the interfacial angle? The angle between the two adjacent faces of a crystal is considered to be interfacial angle. For example, as I can draw here, this is a cube. These are the two faces, and the angle between these two faces are considered as the interfacial angle. Here is some other points also, like here 6 faces in this cube. I can see top, bottom, left, right, back and front. Okay. If we discuss about the interfacial angles, then there is a law of constancy of the interfacial angle, which you need to write also if you want to write. I'll dictate it, that the interfacial angle for a particular crystal lattice remain constant no matter what the size of a crystal is. Whatever will be the size of a crystal, the interfacial angle will always remain same. Second subtopic is our unit cell, in which we will discuss about the classification on the basis of the location of the lattice points within the unit cell. So, which are considered under the topic of types of unit cell. As I told you, what is a unit cell? It is the smallest smallest part of a crystal lattice. Okay, so now if we will discuss about the types of the unit cell, so we have to understand it very clearly, as it is a good topic, important topic. Which comes in various exams like plus 2 exams also, JEE, NEET, Advanced and JAM also. Okay, so second is the type of unit cell. So first, there are two types of unit cell. When we will discuss about the unit cell, types of unit cell, two types of unit cell, primitive and non-primitive. Okay. When we will talk about the primitive unit cell, it means all the lattice points are present in the corners only. Then the type of a unit cell is considered as a primitive unit cell. You can see a basic unit cell in which this is a cubic lattice, and here all the points, all the lattice points, all the atoms, sorry, not the lattice point, all the atoms are present, atoms or the molecules you can say, are present in the corners, are considered as primitive. Whereas if the lattice points are present in the corners as well as in other than the corners also, then this is considered as non-primitive cell. For example, if the lattice points are in the corners For example, in one facial, like this. So this is a non-primitive type of a unit cell. Okay. Now for primitive it is very easy to understand about that because it is only present at the corner. But for non-primitive we will go further and discuss about the non-primitive one. Okay. So first of all, in the non-primitive we say that all the lattice points are not only present in the corners but also present at some other specific points. So let's take one. First of all, we see BCC type, like body centered. We used to study the body centered cubic unit cell, in which what we used to see that it is a cube. Like for example, this is a cubic lattice in which all the atoms are present in the corners as well as in the body center also. This one you can see. So this type of non-primitive cell will be considered as body centered cubic unit cell. Second is a face centered cubic unit cell. We will see face centered. For FCC is the face centered cubic unit cell. Okay. Here are all points are present in the corners as well and in the faces as well. So as there are 6 faces, the total number of ions, if we will see the total number of ions, so they will be, you can see 6 plus 8, right? So there will be 14. So in FCC type of unit cell, 14 ions are present in the lattice. Third is a end-centered cubic unit cell. Generally we see that the end-centered is simple, that all the lattice point at all the corners and any 2 of the opposite faces is considered as end-centered. You can see this by the example, it will be very clear. All the lattice points as well as 2 of the adjacent opposite faces. This one, opposite faces. Okay. So here how many, if I'll ask how many number of ions will be there. So here 8 plus 2, that is 10. Our, this one was the third. Our fourth and the last unit cell, type of unit cell we will discuss is the edge-centered unit cell, which is actually a hypothetical one. So in edge-centered unit cell, in the all corners and all edges. In the all corners and all edges. These are the edges, right? So here the corners are 8 and the edges are 12. So total number of ions is 20. Okay, now as we see, the last point is the classification on the basis of axial length and bond angle. It's a very cute trick, not the cute one, but actually it's a very good trick to, there's a trick to learn it and I'll discuss about it. Okay. So, let's continue. Classification on the basis of axial length and bond angle. Okay. First of all, you have to learn a mnemon, that is cute my ma'am, right? Okay, cute my ma'am. So by this we will see how, first of all, cubic. We will discuss cubic. By cute, we will discuss cubic. Second, tetragonal. Third is the orthorhombic. Okay. Fourth is the monoclinic. Not the my, actually it was our, cute our mom. Okay. Cubic, tetragonal, orthorhombic. Then we will see monoclinic. Okay. Next is the triclinic. Then hexagonal and rhombohedral. If we will see about the axial length and the interfacial angles, so axial length and the interfacial or the bond angles. Here in cubic, all lengths are, edge lengths are equal. A, B, C, A is equal to B is equal to C. Bond angle A is equal to B is equal to alpha, beta, gamma is equal to 90 degree. For tetragonal, A is equal to B is equal to C. There is a trick also, if I will discuss about it. Let's see, first of all, do like this. Okay. When you come from the down to up to down, you see axial length like 0, 1. First of all 0, 1, then 2, 2, 2, 1 and 0. So there will be 0, then 1, then 2, then 2, then 2, then 1 and then 0. This type you can cross the number of edges which are unequal in the lengths. So this is simple, you can easily learn it. It is a very good trick. 0, 1, 2, 2, 2, 1, 0. Okay, so final is the alpha, beta, gamma. 90. In the tetragonal we see alpha is equal to beta is equal to gamma is equal to 90. This is 90. Okay. Next, third is the alpha, similar for the orthorhombic is alpha is equal to beta is equal to gamma is 90 degree. For the monoclinic one, we see that alpha is equal to gamma but beta is not equal to 90. Alpha is equal to gamma but beta is not equal to 90. Next point is that alpha is neither, none of the in triclinic, nor alpha is not equal to beta, not equal to gamma even, and which is not equal to even 90 degree in the triclinic type of cubic lattice. Second, in hexagonal, alpha is equal to beta but gamma is equal to 120. Alpha is equal to beta, gamma is not equal to 90 but it is equal to 120. Third and the final one is rhombohedral, in which alpha, beta, gamma are not equal to 90. So this was the final discussion of the topics. I hope you will and you have understood. Thank you.